Welcome. This is the second chapter of the Wafer story, a deep dive into semiconductor customers. Today, we'll explore how semiconductor devices mirror the human body, the dramatic shifts in memory and AP market leadership, and the powerful lock-in strategies that define the non-memory world. Let's begin. If we compare semiconductor devices to the human body, we see, hear, remember, think, and move. Remarkably, semiconductor devices work in exactly the same way. CIS, we see. Analog, we feel. DRAM, we remember. Logic, we think. NAND, we store. Discrete, we move. Each device plays a unique and essential role, just like the organs in our body. Semiconductors are, in essence, the digital human body. The memory semiconductor industry has seen dramatic shifts in leadership over the decades. In the 1970s through the early 1980s, the United States led the world. Companies like IBM, Intel, and Texas Instruments commercialized DRAM for the first time. Then, from the mid-1980s through the early 1990s, Japan dominated. NEC, Toshiba, and Hitachi nearly monopolized the DRAM market. Quality and manufacturing meant Japan. That was the formula of the era. But from the 1990s onward, Korea launched its great counterattack. Samsung Electronics and Hyundai Electronics, now SK Hynix, led the charge. In 1992, Korea achieved the #1 position in global DRAM. Bold investment and cutting-edge process technology surpassed Japan. The secret? Relentless, aggressive investment, even during downturns, and an obsession with being first in the world. Korea's semiconductor strength is the spirit of never stopping.
From the 2000s through around 2010, the memory industry entered a brutal chicken game. Samsung, Hynix, Elpida, Qimonda, Micron, countless companies competed fiercely. Prices collapsed. Profitability hit rock bottom. In the end, Qimonda and Elpida went bankrupt. Micron acquired them. The market restructured into a survivor-takes-all landscape.
From the 2010s to today, the market solidified into the big three: Samsung, SK Hynix, and Micron. With DRAM and NAND effectively oligopolized, pricing and investment became stable. Now, in the 2020s, we face a new era, the age of AI. The battleground has shifted to HBM, high bandwidth memory. As AI server demand explodes, SK Hynix has seized the HBM market, wielding powerful influence in DRAM. Meanwhile, Chinese players like CXMT are advancing rapidly. The question is, who will be the last one standing? In the AP market, the 1990s through early 2000s belonged to Intel and AMD, the PC CPU era. Computing meant CPU. IDM companies that designed and manufactured in-house dominated. But from the mid-2000s, smartphones emerged, and the mobile AP market was born. Qualcomm led design. TSMC handled manufacturing. A new division of labor appeared, the fabless model. This was the beginning of the mobile revolution and the rise of foundry as a business model.
After 2010, smartphones exploded in growth, and the center of power shifted entirely to mobile. Apple, Samsung, and Qualcomm strengthened their own AP design capabilities, ushering in the fabless era. TSMC's process technology advanced at breathtaking speed. From 2016 to 2020, TSMC created an overwhelming technological gap. When Apple moved all its foundry volume to TSMC, the 7nm and 5nm process race was decided. TSMC had changed the rules of the semiconductor game. From 2020 to today, the battle among big tech companies for 5nm and 3nm leadership is fierce. Apple, Qualcomm,
and MediaTek's advanced chips are almost entirely produced at TSMC. Samsung continues to struggle with yield and process stability. TSMC's dominance continues. Now, we are entering a new era where AI and mobile converge. On-device AI, running AI computation directly inside smartphones, is becoming critical. TSMC's ecosystem, combining process technology with AI optimization, grows stronger every day. The future of semiconductors will be a battle of integrated ecosystems, from design to packaging to AI optimization.
Why do non-memory customer rankings rarely change? If memory is a competition of price and performance, non-memory is a world dominated by lock-in, technology that binds customers tightly. The secret? Once a component is chosen, it stays for over a decade. Let's look at analog semiconductors, discrete devices, and image sensors. Companies like Texas Instruments and Infineon have held leadership in industrial and automotive sectors for decades. Power semiconductors and analog chips, once designed into a product, are used consistently for 5 to 10 years across the product lifecycle.
The first reason is certification and trust. In the automotive sector, the qualification process takes 3 to 5 years. If a single component fails and triggers a recall, the costs are enormous. Manufacturers simply refuse to change a verified partner. The second reason is design lock-in. From the earliest design stage, circuits are built around the specific characteristics of a chosen semiconductor. Changing one component means redesigning the entire system, a massive switching cost. Non-memory is not about speed and performance like logic or AP. In analog and discrete, stability, proven technology is the highest technology. That wall of trust, built over decades, is the most powerful barrier to entry, protecting the non-memory giants. Semiconductors are not just components. They are the nervous system of the modern world. Memory tells the story of bold investment and survival. AP tells the story of design innovation and ecosystem dominance. Non-memory tells the story of trust and lock-in that spans decades. Understanding your customer means understanding which game you are playing. And in the semiconductor world, the rules of each game are completely different. Thank you.